Hello everyone, my name is Joe Fairley, certified prosthetist, owner of Ascent Fabrication, and director of business development at Noura. Noura is an innovative new 3D scanner that is capable of scanning the inside of prosthetic sockets or casts, as well as orthotic casts for that matter, with accuracies of up to 0.3 millimeters. This is really groundbreaking because we're able to now take any heat modifications that we've done to these prosthetic test sockets, or just capturing that anatomy of that patient from that hand cast that you've just done. So what we're going to do first is simply power on the machine. On the left-hand side here, we have the power button. The arm starts with the scanning head all the way down toward the platform. We'll wait just a few seconds for the screen to load. All right, so now that the screen has loaded, what we're going to do is first home the machine. That means that the head is going up to the very top homing position. So here on the screen, you'll see just a couple different buttons, the first of which being home. The second one underneath that is start. And there's a third one down in the corner, bottom right corner, called settings. Well, right now, we're just going to focus on homing the equipment. So we'll go ahead and hit home. This is going to bring the arm all the way up to its starting position. Now on the platform, we do have a 4-hole pattern in the base so that we can actually screw directly into it with any 4-hole adapter coming on the distal end of any test socket. If you don't have some kind of attachment for the distal end of a socket, maybe you have a cast, or maybe you have another socket that doesn't have a 4-hole attachment there yet. We also have a 4-armed clamping system that these simply slide in and out of place. And there is a screw to hold them down tight. And I'll show you just how that operates in just a second. So now that the machine has homed, what we're first going to do is prepare the area. We have the 4-hole attachment plate, which we're going to use first. So I'm just going to screw this into place. Now that we have our 4-hole screwed into place, what we do need to do to prepare a test socket or a carbon fiber definitive, if it is a transparent socket or a dark colored socket, we do need to scan those sockets with the ASA blue scanning spray. So we'll go ahead and do that and get started. All right, now that we have our socket sprayed, we would suggest doing this in a well-ventilated area or even outside. You certainly don't want to be inhaling more than we really have to. So we will simply screw on the socket into place. All right, now that I have that in place, all we're going to do to start the machine is just hit start down here on the bottom. Now we do have one other screen that pops up. What we're going to see here is textured scan. That's actually going to give us the color in the scan. So you'll notice that I have some colors around the socket edges right now, around the fibular head, just to kind of indicate some areas. So you could indicate alignment with your socket. In setting up the alignment on the platform itself, it's crucial that we have the scanner head go directly down into the socket as far as we can possibly go. So that may not end up being the alignment that you want for your end prosthesis. So what we would suggest at the beginning is to draw an alignment line anterior and draw an alignment line laterally inside the socket, so that then we can capture that in CAD and translate that after the fact. So I'm going to go ahead and hit textured scan. And now the first pass of the scan is going to come down with the green light laser. The green light laser, again, is laser triangulation scanning down to 0.3 millimeters of accuracy. Now with this colored scan, we will be using just a USB stick that will plug into the outlet there as soon as this is done scanning. And we'll be able to save it, name it whatever we'd like, and then we can translate that to the NouraSoft application. So we are going to scan the entire inside part of the socket the head is going to come down into the socket as far as it possibly can, and it might stop about an inch just above the distal end of the socket itself. So it'll do the first pass with the laser, and then you'll notice it home back up again, and then the second time it will come down and actually take pictures and grabbing the color in the scan. And that whole sequence takes about 5.5 minutes to do a full color scan. Right, now we've taken the full inside scan of this prosthetic socket. The head of the scanner is going to go back up and home, and then we will end up seeing actually the mesh being generated for about 30 seconds on screen. That's the internal computer just processing that scan data and coming up with that full mesh point cloud. So we'll wait for that mesh to generate. Now that the mesh has generated, on the on-screen touch UI, we can rotate around the model by scrolling down, scrolling up. You can see the back side of the model by scrolling all the way up, and we can also rotate around by scrolling to the left or to the right. Now you'll notice that it becomes more pixelated as you move the model around. That is simply the mesh taking some time to generate the image while you're moving it. So if we want to save this, we can plug in a USB into the port. We will click Save. If the USB has not been actually detected here, you click on Refresh in order for it to be detected. And then under Scan Mesh, you can enter a file name, clear that, name it whatever you'd like. We'll do BK, and then today's date. So now that we've saved that to the USB, we can then take the USB back out, and we will be transferring that over to our computer to then use the NouraSoft application.